Hello there and welcome. I'm assuming that if you came here, you received one of these in the mail. This is a YoshiPi kit, and you need to put it together so that it looks like one of these. Let's go over to the soldering station and discuss how we put this thing together. The first thing we want to do is do a quick inventory of our kit. So here we have the YoshiPi board itself. We've got some resistors, integrated circuits. This is our real-time clock, the Raspberry Pi Zero. We have some 2-row headers, some 1-row headers. These are screw terminals. This is our Grove connector, a couple of buttons, and a display. Now let's look at some of the tools and materials we need to put this together. The first thing you're going to need is a soldering iron. You can get something like this Weller, which is a pretty nice one, or you can get one that is actually much less expensive. The things to look for are you want an adjustable temperature, and you want a pencil style iron itself, something that comes to a point. You don't want something that has like a chisel edge or a beveled edge. You want something that has a nice point. This one, I can actually unscrew this and change the type of tip on it. But something inexpensive is just fine. The important thing though, again, is that it has adjustable temperature. You'll want a tip cleaner. This just is kind of a metal scrub pad in here. You're going to need solder. This is solder I picked up at, I think, Harbor Freight. There's enough here to probably last most people a lifetime. You will need flux. This is kind of my go-to now. It's a paste that's in a syringe, and it comes out as a fairly thick, almost gel. You can see like that. I find this is much easier to apply and requires a lot less cleanup. Though you can use something like this type of flux. This is a liquid flux. And I use a bottle like this with a very small tip for applying it. The problem with this is because it is a liquid, it tends to run all over the board and the components that you're using. I also find this tends to be stickier once it's been heated. So you end up with a bit of a sticky mess on the boards, and you have to do a bit of cleanup after you're done. And the last thing you're going to need is a pair of cutters. These again are not expensive, but you want ones that are really nice and sharp and can get really close to things. Before we start assembling this, let's go over a couple of things. First, why is it that this kit comes completely disassembled and you're expected to solder it together? Obviously, it makes things lower cost for us, therefore it makes it lower cost for you. But really, one of the other reasons is I firmly believe that if you're going to do IoT work, you are going to have to learn to solder. If you're going to build things like this, you're going to need to solder. You want to build something like this, you have to solder. Something like this, you're going to have to solder. It's extremely rare that you will find a board that has everything that you want on it laid out the way you want to do exactly what you need. So you're going to have to assemble something. Building your skills for soldering on something very easy like this is a good start. Next, let's talk about the types of components you have. Really, there are generally two types of components when we're talking about soldering. There are through-hole or surface mount. You can see that your board will have one surface mount component already on it. It's called surface mount because, well, it doesn't have anything that goes through the board. It is attached right to the surface. This is very common today. You'll see this on most everything. The reason is you can get really high density. You can get very small components for surface mount, and you can get a whole bunch of things on a board that is much, much smaller. They're also extremely hard, if not impossible, to do by hand. Here's a classic example, something from Adafruit. You can see all of the pieces on it. Little resistors, capacitors, ICs, connectors, everything all on one side of this board. Through-hole components, as the name suggests, go through a hole. You'll see that this board has a whole bunch of holes in it, and they're marked what goes into each location. Those holes come all the way through the board and will solder to the back. So the component has pins that you push through, and then we solder to the back of the board. This is not going to be an in-depth tutorial on how to solder. I will go over some tips and tricks that I find helpful, but there are plenty of online resources for how to solder. So if you're brand new to this, you might want to take a look at some other videos just to get a feel for how different people do soldering and other, tips and techniques that they might use. When I'm assembling this YoshiPi, the first thing I want to do is I want to put on the integrated circuits. So these, it is important that they're aligned properly. There is a direction or a pin number 1. If we take a look at, say, this one in the middle, you can see, if I angle it, it's got a little dot here and then a notch at one end. This one has a dot but no notch. This one has a dot and a notch. The dot signifies pin number 1. Because these are symmetric, you could put it in this way or this way and it will fit, but only one way electrically is correct. If you look at your YoshiPi, these footprints have a dot or a little notch, and pin 1 is typically square where all the rest of the pads are round. So you can see this is pin 1, pin 1, and pin 1. So what I will do is I'll take those 3 components and push them through the board so that we can solder them on the back side. When I'm starting with one of these components, I tend to like to start down at one end, and you have to squeeze the pins together just a little bit to get it to go in. So I'll start with one corner. You can see I've got just that end in, and now I can squeeze as I move up and push it in. And we are seated. Go back and make sure that you have this aligned properly. So pin number 1 is up here. Now I'll put the other 2 on. Now before I solder these, I'm going to triple check that they're aligned properly. Pin 1 is here, pin 1 is here, pin 1 is here. The nature of these, since we had to squeeze it to go in, they won't fall out if I tip it upside down. So now the pins are along here. So what I'm going to do is first apply flux. Again, I'm going to use this. You could also use a liquid, but you want to flux every one of the pins. You don't need a whole lot. I definitely put more than I needed there. But you want to make sure that there's enough that when that flux heats up and melts, it gets good saturation of that pin. That will make the solder flow around that pad and down into the via, which is the hole for this. It'll go all the way through that hole and basically allow the solder to flow very easily. If you don't use flux, it is very, very difficult to get the solder to stick and to flow where you want. So definitely always use flux. We'll turn on our soldering iron and let it preheat. This button will start blinking when it is ready. This only takes maybe 15-20 seconds in order to come up to temperature. Again, this would depend on your soldering iron. I'm going to start with a temperature of about 450 degrees Fahrenheit. You can see the melting temperature on this is 361. It needs to be hot enough to readily melt the solder and to be able to put heat into the part. So the pin or whatever it is you're soldering to needs to come up to temperature. But you don't want it too hot that things just burn off or flow away really quickly. Before I start soldering, I'm going to take the cleaner and I'm going to take the tip nice and hot and just twist it in here to get it clean. Clean off any burnt residue from previous flux or solder jobs, anything like that. Get it nice and clean. Then we want to do what's called tinning the tip. Just take some solder and melt it on here. Make sure that it's got a good coating on it, especially if it's new. Now I'm actually going to clean that off a little bit. You can see the tip has a nice layer of solder on it. I tend to approach this. I'll pull a whole bunch of solder off, especially since this is a fairly heavy spool, so that I can move just the solder around like this. I'm going to come in with the solder from this angle and the iron from this angle, so kind of 90 degrees perpendicular to the row of the pins. I'm going to come in just below the pin that I'm soldering, and I'm going to actually touch it so that it gets hot, and then I'm going to come in with the solder, and it goes in that gap between the point and the pin to fill it in. And once soldered, you'll see we've got good coverage of the entire pad and pin. It's kind of convex in its shape, so it's not a huge glob. It's just enough to hold that pin in. Initially, when I did this first pin, the temperature was a little bit cold, so the solder did not want to flow very well, so I turned the temperature up to 550. You'll find that depending on the component that you're working with and really the solder that you're working with will drive the temperature that you want to go with. So I usually start cool and then work up to a temperature that is a good flow temp. Now that I have this one done, I'm just going to walk through, come down each row, and solder all of these in. So touch it to the pin and then come in and flow some solder. I can also go above it and do the same thing. And now this component is soldered in. It's important to be in a comfortable position that you can reach all of these pins. Before soldering them, again, I like to push on them, make sure they're fully seated so that they're not sticking out. Now, here's a good one. What happens when you have a bridge like that? Oh no, I made a mistake, and it's bridge solder across two pins. Don't panic, it's not a big deal. You just get it warm, go right between them, and break that bridge. Then continue soldering. The reason that that bridge occurred was I was feeding solder too fast, and it was building up on the tip of this iron, and when I moved, it bridged between two pins. So if you find you're bridging a lot, you're probably feeding your solder a little too fast. It also might mean you're a little bit cold, and the pin itself isn't getting hot enough to allow that solder to wick in. But after you do this a little bit, you'll get into a flow that it goes quite quickly. And there we have it. The ICs are all soldered in place. Next, I want to do these resistors. You can see there are 4 10K or 10,000 ohm resistors and a pair of 470 ohm resistors. Resistors have colored bands on them that can be decoded to the resistance and tolerance, but nicely we have 4 and 2, so we know that these are the 10K and these are the 470s. What I'm going to do is I'll start with the 10Ks. I'm just going to remove the paper from them. Then each resistor, I'm going to bend into a U-ish shape. So I'll bend it here and here. And then this can poke right through the through holes for this resistor. Resistors are not directional, so it doesn't matter whether it's this way or flipped 180. I do like to line them all up so the bands are the same, but it really doesn't make any difference on orientation. So I'm going to populate all 6 of these. Once you have all 6 of them in, you'll notice that these tails are much longer than they need to be. That's fine. What I'll do is I'll flip it over, and now I'm going to flux every one of these connections. Now these, I'm using my finger to hold them in place. Be aware that if I heat this, there's going to be heat transfer up through this board. So if I'm touching the metal here, it's going to hurt. So what I'm going to do now is I'm going to take my solder, and I bent it so that I can just get to it because I have one hand busy here. And I'm going to build up a nice sized globule of solder on the end of the tip here. Then I can come over and I can just touch it to it, and that is transferred to that component. So that component won't fall off anymore. So now I can move my finger down to here, a little bit more solder, and do the end of this one. So now it's in place. I haven't done the second side of these, but these are now held on by that solder, and I don't have to worry about them falling off. So I'm going to move to these 2, and then these 2. Okay, now I don't have to worry about them falling out of the board. I can set the board down and solder just like I had before. Okay, these are all in place. Double check visually that you got solder on every one of them. And now we're going to use our cutters and remove these tails. You don't have to go all the way down against the board, so try to leave the solder bubble. Just remove the end of it. So we still have a nub sticking out. We've got standoffs for this, so it's fine if it's sticking out of the back of the board like this. You don't want to cut all the way down into the solder because you might cut the solder completely away and then it will no longer be attached to the board. Once you've got them all cut, go ahead and again double check that all of them are soldered and that you've got good solder on each one. If you've missed one, it's not a big deal. Just go back and hit it with the soldering iron. Next, I'm going to put the buttons on. The buttons, their pins are rectangular, so the distance this direction is different than the distance this direction, so they can only be oriented one way. There is no top, so you just put it on. Make sure they are fully seated. Push them down. I'm going to do the same thing. I'm going to use my fingers to hold them in place. If you're not comfortable holding both of them, you can always do them one at a time. And just like all the other components, we're going to flux. And then I'm going to do that single dab to hold the components in place. So one pin, make sure you're holding it tight against the board. I got that one pin done. And one pin over here. These ones are a little bit offset for the hole. That's why you might see me heat from one side and then the other to get solder to flow across both sides of it and all the way around that pad. But now we're in, so I can lay it down and solder the other 6 pins. Alright, the buttons are in. Next up, I'm going to put on the Grove connector, which is over here. This is a directional one, so we want it with the opening of the connector toward the edge of the board. And just like before, flux and solder. Before I solder the rest of it, I'm going to make sure it's flush. If it's not flush, if it's up a little bit, you can always push in on it and reheat that pin to get it to seat. Once you know it's seated, you can then do the other 4. Check your connection. Make sure you don't have any solder bridges. It looks like I may have a bridge right here. So just heat it up and remove it. Next, I'm going to do the display connectors. Those use these female single row. Obviously, this is much longer than we have here. This is 14 pins. So you just count down 14. You can double and triple check this. It's right there. So I can actually just twist it and it breaks off. And now this is ready to go in there. The important thing on headers is to make sure that it's not angled like this or this in the board. You want it nice and flush and perpendicular to the board. So I'm going to flux this. And again, I'm going to do 1 pin. I'm going to hold it perpendicular to the board and get this 1 pin. You can see, oh, I didn't quite get it right. Well, at this point, since there's only 1 pin, it's easy to straighten out. So I can straighten it out. Make sure that you're all the way against the board, so it's fully seated at both ends. At this point, I like to do the other end, especially on longer headers like this. So I already did this end up here. Now I'm going to come down, put a little bit on that one. So now I have both ends done. It is flush against the board and it is perpendicular. Now I can go ahead and solder it. Double check that you got all of them done. And now we'll move on to the one that goes on the other end of the display. This one is just 4 long. So I'm going to count out 4. And snap it off. When they get real short, sometimes they're a little bit more difficult to snap. If that's the case, just go ahead and use your cutters to remove the header the length you need. Trying to hold it perpendicular and all the way in, so make sure that it is where you want it. Now, because this one is short, I'm not going to do both ends, I'm just going to run down the length of it, and I will start at the other end. While I'm doing single row female headers, I'm going to jump over and do the microbus, which are also single row female. These ones are 8 long. You can see that one, oh, it broke in the wrong spot. It's not a big deal. I can always just use the cutters and remove those too. And now I'll get another 8. Again, on this one, I could count them out and cut it. And this is going to go in that one. I'm just going to do these one at a time If you need to resolder a pin, maybe you didn't get quite enough on it, do an interior one first and then go back. Otherwise, this one might melt out and it'll shift the connector on the other side. Do the second side. Alright, we have all of the single row females done. Next I'm going to do single row males here. This one is 5 positions. The single row male, same thing, we can just count out 5. You want the short end to go through the board, not the long end, so the long end will be sticking up. These ones, because it is bare metal, this is where that heat transfer makes a big difference. I will not want to have my finger on this pin here at the end when I solder it here, or it will burn you. And oh no, it's way off. Now this one I could push over, or I can simply reheat that pin because we only did one and straighten it right out. That's why it's important to only do one pin and then check everything. Next, we're going to put in the screw terminals. It's very important that you pay attention on this one. On this side, we have holes, and on this side, you'll see shiny terminals. These are not the same. If you just quickly glance at them, they seem to be, oh, it's the same either way. You might end up putting it on incorrect, 180 out, but the wires can only go in one side. So if you look at this one, see how that's just a metal pad? The wire cannot go in here. The wire goes in this hole. They've got a little step on them. The hole needs to face out to the edge of the board. So I'll just start at this end. Doesn't matter which direction you start. I'll put it down in there, flux it, and get one. Now, these, just for appearance, I like them to be fairly straight, so I'll try to make sure that it is straight on the board here. And then I'll solder in that one and verify everything is where I like it. Now I'm going to attach all of these with just a single pin, and then I'll come back and final solder all of them. You will notice there's one here that's just a 2. Do not put anything in that. That's unpopulated. These you can use if you're not using a touch screen, but if you use the touch screen on the display, these are also used by the touch screen. So when you're just getting started, I would recommend not even populating these. Again, make sure you've got it facing the right way. These tend to be the ones that I'll have a gap on one side when I'm soldering because I'm going too quickly. So just make sure that they're seated all the way against the board. If you have it up a little bit, you can just give it some pressure again, go back and reheat the pin. Alright, I have all 5 of them in place. They are seated against the board where I like them. Now I can come back and final solder the remainder of those pins. Alright, we are almost done. Really the only thing left to solder are our double rows. Now, we can go 2 different directions on this. My preference here is to put the double row male onto the board here. Then this double row female is going to go onto the back of our Raspberry Pi here. You could put the female on this board and the males here, but This works just like before. These are a little bit easier to keep perpendicular to the board because it's wider. And again, because this is a long one, I'm going to do one up here and one down here. But start with just one. Make sure everything is straight, fully seated. Ouch. And again, make sure you don't have your finger on that pin. I just burned myself because I had my finger on that pin when I soldered it. All right, and now we'll just run down the row, and then I'll flip it around and run the other side. On connectors like this, it's really important that you check to make sure you don't have any solder bridges. These ones are the easier ones. And they're, again, easy to fix. But you can just pass down through between the pins with your soldering iron. That'll usually clear them out. If it doesn't clear it out, just use your cleaner, clean the tip to remove any solder, and then do it again. So we're done soldering on this board. Now we just need to solder our connector onto our Raspberry Pi. This is going to go on the back side of the Pi, like this. Otherwise, it's identical to what we've been doing. Now you may have noticed I only fluxed down one row of pins. Sometimes that's a little helpful because the heat might make it all melt on the other side while we're working on the right. All the stuff on the left will melt off, and then there will be less flux. So I'm going to run this, and then I'll flux the other side and come back. But again, make sure we're perpendicular and fully seated. Then I'll do the other end. When you're doing this one, you've got a component over here that you don't want to unseat, so be careful you don't put a bunch of heat over onto one of these resistors. In that case, you might want to go to the top side of the pin here, just to make sure we stay well away from that other pin, or that other component rather. Don't be afraid of it. It's kind of hard to actually get so much heat in that you'll cause it to come off, but it's worth being aware of. Now that we have everything soldered, we can assemble the board. We've got a hardware kit here. Take a look at these standoffs, and you'll see that you've got two different lengths. You'll have 4 short ones and 2 long ones. The 2 long ones are for the Raspberry Pi, and the 4 shorter ones are for the corners. So I'm going to put the corner ones in first. Put a nut on top, and the standoff comes in from the bottom side. This allows the board to sit on your bench without any of these solder points touching anything, so it's a stable surface. It also prevents it from shorting out on anything down below. Now we'll take the longer standoffs. They're going to go in these outer holes. The screw comes in from underneath, and the standoff attaches like that. Now we take our Raspberry Pi, line up the pins, and these standoffs, those pins are going to go through the holes on the Pi. If you find it is really tight, loosen these screws so that these can move around a little bit, and we push it down on. Next, the display goes into these and these. So tend to line that up. Then come back over here. Give it a little bit of a push. Like that. Finally, we take our real-time clock, and it just plugs in right there. There you have it. We have assembled our YoshiPi.